Welcome back. Now we're going to get our readings that we took from the supply and return, and we're actually going to plot it on the psychrometric chart. So let me write it down. Dry bulb 56, wet bulb 50. Return air is dry bulb 72.5 and wet bulb 64.4. So now we're going to start plotting this on the chart. So the first one I'm going to do, and it doesn't matter which one you start first, I just like starting with the return air, but you don't have to. So I'm going to look for the dry bulb of 72.5. So the dry bulb temperature, just to recap, are the numbers on the bottom. And I'm looking for 72, so this is 70, 72.5, and I'm going to go straight up with it. Remember, dry bulb is all the way up and down. Now I also need to plot the wet bulb temperature, which in this case is 64.4. Okay, so these numbers right here are the wet bulb temperature. So, okay, this is 45, 50, 55, 60, 65. So 74.4 is around here somewhere. So that's where the wet bulb and dry bulb temperatures meet. So now from here, we're going to do something called enthalpy. Does anybody know what enthalpy is? Enthalpy is how much BTUs this unit actually has removed. So what I'm going to do is, okay, let me backtrack. What we're going to do is, where is the enthalpy line? So the enthalpy lines are these right here, 10, 15, 20, and all the way up to 45 enthalpy. So what you do, remember the wet bulb line, you go straight up. That right there is, let's see, 26, 27, 28, 29, like 29 for the return, 29, I would say, 0.1 enthalpy. Okay, so that's for the return air. But now we also have to do the moisture content. So how do we find the moisture content of that air? What we do is we draw a line left to right, straight all the way to read my moisture content. So 10, 20, 30, 40, 50, 60, 70, 80, so around 78.8 moisture. So the moisture for the supply, the moisture for the return is 78.8 grains of moisture per pound of dry air. Are we done? Not really. Now we need to plot the supply air. The first thing I'm going to always plot, always start with dry bulb, is the dry bulb temperature. Okay, this is the 20 dry bulb, 25, 30, 35, 40, 45, 50, 55. So 56, is a little bit over. Okay, so now that I plot the 56 dry bulb, now I need to find the wet bulb temperature. The wet bulb temp, I'm sorry for that. The wet bulb temperature, and the wet bulb temperature is 50 degrees, okay? 25, 30, 35, 40, 45, 50. So now I plotted the 50 wet bulb temperature. So now I'm going to find the enthalpy line for that, which I'm going to continue with the wet bulb line and go all the way to the enthalpy line. Okay, so 10, 15, 20, 21, 20.5. Enthalpy. So now you might ask me, am I done? Not exactly. We still have to go and find the moisture content of the supply air. So how do we do that? Oops, that's not a good straight line. Straight line all the way to the moisture content line, or grains of moisture per pound of dry air. Let's see what that is. Okay, we got 10, 20, 30, 40, maybe 41. 41 grains of moisture. Does this unit remove moisture or not? How do we find that out? What we do is we get the supply grains of moisture and subtract it from the return grains of moisture. Got the answer right there. Yeah. So 78. Can you see me over here?
Yeah.
78.8 subtract the 41 equals 0.73. So this unit has removed a lot of grains. It actually removed 37.8 grains of moisture. Is this unit working right? I cannot determine that because, not yet anyway, because I need to find sensible and latent heat. And how do we do that, right? This go back to grains of moisture. This is the supply, and this is the return. Now, you see this grains of moisture line right here? When it intercepts the return, what you're going to do, on the same angle as the enthalpy line, you're going to draw a slant. To the enthalpy line, and what that did is going to divide your sensible and latent heat. Before I continue, let me define sensible and latent heat for the students that are having difficulty. What is sensible and what is latent? Sensible is actually bringing the temperature down, how much heat was absorbed in that air conditioning system, which is important. But the most important one that we deal with is latent. And latent is how much humidity is being removed from the system. Typically, you want 50-50 or more latent than sensible heat. Let's see if this unit is removing more sensible than latent heat or more latent heat than sensible heat. So right now, 10, 15, 20, what did I say it was? Okay, so 20.5. Okay. Here, okay, 20, 21, 22, 23, 24. So 24.4. Okay. You may say, okay, I understand what that line is, because you put a 24.4 enthalpy, but why am I writing this down on the board? Basically, the AC has to remove sensible heat first before it removes latent heat. So how much sensible heat, latent heat, has this thing removed? 20.5 minus 24.4 Is that math done correctly? Yeah. So sensible heat in this unit removed was 3.8 sensible. Okay, so it is removing sensible. Is it removing latent heat? So now we have to find this last one right here. So 25, 26, 27.
It's 3.9.
3.9. Sorry. I did the math wrong. See, even teachers make mistakes. So 25, 26, 27, 28, 29, 29.2. So right here is 29.2 enthalpy. So what you need to do is get 29.2, subtract the 24.4,
Eight.
Latent. So is this unit working right? Yes, it is, because we removed 3.9 sensible and 4.8 latent. So we're removing more latent than sensible. So this unit actually is humidifying, or I'm sorry, dehumidifying that air. So this unit is working 100%.
Now, if the unit is not working correctly, would the inverse happen?
Like
less sensible, less latent and more sensible?
Yes, it can. And if that happens, it's very dangerous, because you can start growing mildew and mold in your ductwork and in your house. And there's many reasons that could happen. The charge is not correct, the unit is dirty, or maybe your unit's working 100%, but the heat load calculation said you needed a 3-ton, but the homeowner wanted you to put a 5-ton, and since that unit is so big, it brings that temperature down so fast, it doesn't have time to remove any latent heat.
Excellent. So this concludes this part of psychrometrics. Yes, you can get superheat and subcooling, but now you can find out what the system is really doing. It lets you know much more than if you need refrigerant. Stay tuned for the next one.